Yes, ma'am. I started.
Okay.
Can you hear me?
Yes, sir.
Today we will be discussing matrices and determinants. Okay. Yeah. So I have taken some 30 questions. Those who are new to the class, I'll be explaining them. The questions as well as the concepts which are related to the questions. Okay. Those who have any doubts, just type in the chat box, guys. Okay. Yeah. I'll be checking after every question. Okay, guys. So let us see the first question. The number of different orders of matrix having 12 elements. Okay. So you all understand by what is order, right? Okay. A matrix has 12 elements. Now, if the order of the matrix is m by n, then number of elements will be mn, right? Like if the order of the matrix is 3 by 5, the number of elements will be 15. If the matrix has 3 rows and 5 columns, then it will have 15 elements. Now, what they have given that the matrix has 12 elements. So what are the possible sizes of the matrix, correct? So the matrix size can be 1 by 12. You have to choose the row number and column number, that is m and n, in such a way that the product must be 12, right? So 1 by 12, 2 by 6, 3 by 4, and just reverses 4 by 3, 6 by 2, and 12 by 1. So you can see that totally 6 different matrices are possible. Okay. Next. Yeah. In matrix, you will see that there is something called symmetric matrix and skew symmetric matrix. Okay. So before coming to the question, so let me just give a similar type of questions how to solve. Okay. Just I'll give the idea. A symmetric matrix is a matrix whose transpose is the matrix itself. Okay. If A transpose is A, then it is symmetric matrix. If A transpose is minus A, then it is skew symmetric. Okay. Now, how to check a given matrix is symmetric or not? If the matrix is given, then let's say symmetric or skew symmetric, we see for square matrices only. You have this diagonal. Let's say it is a 3 by 3 matrix. Above diagonal, 3 elements will be there. Below diagonal, 3 elements will be there. Now here, if A is there, then here also A must be there. B means here also B. Here C is there means here also C must be there. So if I give a matrix 1, 2, 3, 2, 7, 1, 3, 2, 4. Now, is this symmetric matrix or not? Let's say if I want to check. Now, ignore the diagonal elements because whether the matrix is symmetric or not, it is not dependent on the diagonal elements. So what you need to check is whether the mirror elements are same or not. Now here you can see that 1 and 2, these two are not same. So it is not symmetric. Okay. And same way, I hope just if I revise, skew symmetric. For a skew symmetric matrix, the diagonal elements must be 0. And if I write, let's say 1 here, the mirror element should be negative of it. If I write 5, then minus 5. Minus 7, then 7. This is a skew symmetric matrix. Okay. Now, this is how you identify when the matrix is given. Okay, fine. Now, sometimes they will give something like this. Like A and B are symmetric or some information. For example, let's say. So for that, you should know transpose rules. Very simple, guys. just let me write down here. AB, just you need to know only one or two. AB whole transpose is B transpose into A transpose. And whenever you have A square transpose, you can write it as A transpose whole square. That can be written. And if you have A, B, C, D whole transpose, then it will be reversed. D transpose, C transpose, B transpose, and A transpose. Okay. So let's use this funda. Okay, we'll do one thing. We'll solve this question. Then I will extend this one. Like what they have given, A and B are symmetric matrices. Then A, B, A is. Always, whatever matrix they are asking, you take that as X. X is ABA, let's say. Let's do X transpose. ABA whole transpose, which is A transpose in the reverse order I am coming. Then B transpose, then A transpose. A transpose is what? Minus A, because they have given A is skew symmetric. Acha, they have given symmetric. So, okay, so it will be plus A. You can see that how if a different kind of information is given, you can still write this one, right? For example, if they have given A is skew symmetric and B is symmetric, then in place of A, you will write A transpose, you will write minus A. Okay. In place of B transpose, you will write B because B is symmetric. Accordingly, according to the question, you just have to write the next step. Then what we are getting ABA only. So what is ABA? That is X only, no? From 1. So X transpose is equals to X. So it means X is symmetric. So what is X? ABA. ABA is symmetric matrix. Now there can be questions like if A is skew symmetric and B is symmetric, for example, let's say, then A power 5 B cube A power 5 is it symmetric or is it skew symmetric? Okay. Again, what you do, take X. Which one? A power 5 B cube A power 5. What will be X transpose? It is A power 5 B cube A power 5 whole transpose. Now A power 5 is one matrix, B cube is one matrix, like this I will take. Reverse. A power 5 whole transpose into B cube whole transpose into A power 5 whole transpose. Now, this rule, A square whole transpose is there. You can take the transpose inside the power, like A transpose whole power 5. This will be B transpose whole cube. A transpose whole power 5. Now, what is A transpose? A is skew symmetric. So A transpose will be minus A power 5. B transpose is B only because B is symmetric. And A transpose is minus A again. You will get again same matrix, A power 5, B cube, A power 5, which is again X only. No? So X transpose is same as X. So it is symmetric. Okay. That way. So whenever you have these kind of questions where they have given A and B, whether they are symmetric and skew symmetric, and some combination of A and B, they are asking. Okay. Whether it is symmetric or skew symmetric, this is what you have to do. Okay. Any doubts up till now? Let me just check the chat box. This sheet will be shared with you guys. So, because time is less, now I have to go a little fast. That's why. Yeah. You take a screenshot whenever it is required. Yeah. Okay. Now coming to this question, this is a JE question. Okay. But the fundamental which is required for this question is very simple. Okay. In matrices, we all know that AB need not be equals to BA. That is in general. Okay. So for example, if they give what is A plus B whole square, what will it be? It is A plus B into A plus B, correct? Now, before going to this, let's say if you have numbers, that is X, Y, polynomials, what is X into X plus Y, for example? You can write it as x square plus xy, or you write it as x square plus yx. It doesn't matter. Both are same. But in matrices, A into B plus C, if you have matrix A into B plus C, it should be AB plus AC only, because A is multiplied to the left side of B and C. Na? Okay. So A plus B into A plus B. So what do we write? A into A plus B plus next B into A plus B. So you know this formula, that is A square plus B square plus AB plus BA you will get. Okay. Now these two are not same. That's why we can't write in matrices A plus B whole square as A square plus B square plus 2AB. This thing, just like polynomial, we can't write. Okay. It's not allowed. Why? Because of this reason. Okay. But if AB equals to BA, there are so many matrices where AB and BA can be both equal. You can always choose some two matrices. No? It's not like this is never possible. In general, it's not possible. It's not a general rule. Okay. AB and BA both are equal. No, not all the time. Okay. But sometimes it can be equal. So if AB and BA are equal, then in simplifications, very important point, guys. Why? Because on JEE, only based on this concept, many questions have come. So in simplification, you can treat A and B like variables we use in algebra. Okay. You can treat like the variables. So whatever formulas we have seen in algebra, same formulas can be applied here. And you know that it happens very frequently with identity matrix. We know that AI is equals to I into A, which is equals to A. Correct? If you multiply any matrix with identity matrix, square matrix, and IA also will be same, and that will be A. Okay. So A and I are matrices which satisfy the commutative property in multiplication. So now, if I write what is A plus I whole square, now treat them like a variables, x plus y whole square, A square plus B square, like that, I square plus 2 times, you can write it like that. Okay. I square, we know it is I, and A into I is A only. Okay. Now, and also in matrices, if you have ABA, it is not equals to A square B. You can't, if it is x into y into x, you can write it as x square y, na? But you can't do that in matrices, right? The order of multiplication matters. Again, the only reason why this is not equal is because since AB is not equals to BA. But if AB equals to BA, you can do this. Okay. That means if AB equals to BA, if you have A, B, A, B, 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 A, you can combine. How many A's are there? 4 A's. So A power 4. How many B's are there? B power 4. Or you can write it as B power 4 into A power 4. Just treat them like X and Y. Okay. So you can do that. Keep that in mind, guys. Okay. Now, these are the 2 points which are important. And the third point, which is important, is inverse. Okay. You all know what is inverse is. If inverse of a matrix A, it is written as A inverse. If you multiply with the matrix, you will get identity matrix. Either way. Okay. A inverse into A or A into A inverse. Okay. But since we have seen transpose and you already have the basic idea of inverse, remember this rule very carefully. See, again, I'm not going to do the derivation and everything. If required, only I will do. But this is very easy to remember. Why? Because here we have seen where, yeah, A square whole transpose. Like in general, A power n whole transpose equals to A transpose whole power n, like that. Just remember that way. Even that n is minus 1, that is A inverse whole transpose is A transpose whole inverse. Okay. Keep that in mind, guys. Okay. Very, very important rule. And one more. One last point on inverse, that is K times A whole inverse. It will be 1 by K times A inverse. Because this is very easy to understand, because what is the inverse of K times A? Which matrix I should multiply with KA? If I multiply 1 by K times A inverse, no? Scalar will get cancelled. A into A inverse will get I. So this matrix is inverse of Ka. So what is K inverse of Ka matrix? 1 by K times A inverse. That's it. So 3 points we have seen. Yeah. I will just brief it in 1 minute. In general, AB is not equals to BA. That's why we can't do like polynomial expansion in matrices. But if AB equals to BA, you can treat the matrices like variables. And you can do everything what you do in polynomials, algebra, whatever simplifications you are doing, you can do that. Okay. You can change the order. Okay. You can club them. Okay. All those things. And second point, A inverse whole transpose is A transpose whole inverse. And inverse of K times a matrix is 1 by K times the matrix inverse. Okay. Now, one good question on this one is, it is asked in JEE before. That is, if A is symmetric, then A inverse is, options are symmetric, skew symmetric, can't be said. Okay. Ignore the D, I don't remember. Okay. Now, A is a symmetric matrix, then A inverse will be. The answer is symmetric. If A is symmetric, A inverse will be symmetric. The reason is very simple. Now, take X as A inverse. Now, X transpose is A inverse whole transpose, because we want to see whether A inverse is symmetric or not. No? That's why I'm taking it as X, just like we have taken it in previous question. Okay. In these questions, X equals to ABA, like that. Okay. Now A inverse whole transpose is A transpose whole inverse. So what is A transpose? A. So A inverse is what? X. X transpose and X both are same. So X is symmetric. What is X? A inverse. A inverse is symmetric. Okay. So if A is symmetric matrix, then A inverse is also symmetric matrix. That way. Fine. Let's come to the question which is given in JEE. Yeah. Now you see guys. M and N are two 3x3 non-singular skew symmetric. They have given skew symmetric matrices. Okay. What is meant by skew symmetric? M transpose is minus M and N transpose is minus N. Okay. And why they have given non-singular? Non-singular means det is not zero. Because for inverse to exist, det must not be zero. No? That's why. Okay. Leave that one. Okay. Because inverse they have used. No? Okay. Now what they are asking, see. Then something is equals to this, you have to simplify. Okay. But see here, guys, they have given Mn equals to Nn. That means you can treat these matrices like polynomial only. Okay. Directly. So how it will work? M square, N square. What is M transpose? Minus M. Okay. Why minus M? Because it is skew symmetric. They have only given N whole inverse. And this is M, N inverse. Now let this transpose be like this. Okay. Now, this is M square, N square. Just like, if it is a polynomial, how will I write? Minus 1 by M. X power minus 1, how will I write? 1 by X only. No? Like that one line. Right? 1 by N into. Now transpose is there. Actually, I should write, okay, you write down like this, N inverse whole transpose into M transpose. And what is M transpose? I'll do one thing just to avoid confusion. I will not write 1 by M and all, because matrix division is not possible. Okay. Actually, I used it like a shortcut, but let's do it with correct procedure. Okay. So minus Mn whole inverse is N inverse into minus M whole inverse. Okay. Next here, AB transpose I have written like this. Next, M square, N square into N inverse. What is minus M whole inverse? It is like K into A. Here we have written, no? Ka whole inverse will be minus 1 into M inverse. Okay. Next, what is N inverse whole transpose? It is N transpose whole inverse. M transpose is minus N. We already know. Now just simplify this minus, it will go, remove it. Okay. So M square, N square, N inverse, M inverse. What is N transpose whole? N transpose is minus N, correct? So minus N whole inverse will be simply minus of N inverse. Here K is minus 1, guys. Okay. So minus of N inverse will get. That's it. And finally, what is remaining at the end? M. Just like polynomials, these two you cancel. We are only able to do it because Mn equals to Nm here. Okay. And then N inverse, N square cancelled. One minus is remaining. Answer is minus of N square. Okay. Fine. One question only, but you need to know so many different concepts. That's why I've taken this question. Yeah, let me just check the chat box for doubts. Yeah. Okay. Fine. I'll proceed to the next question. It's a very beautiful question, this one. Okay. They have given something like this. M into this is this. They're asking to find the sum of diagonal entries of M. So basically, they have given some equations on matrix M. And they told M is a 3x3 matrix. You need to find M. Indirectly, that is the question. Okay. After finding M, you can always add, no? Okay, diagonal entries. There is another method also where you need not find M, but still you can find the sum of diagonal entries. We will not look into it. Okay. Let us try to find M. Okay. Now, this is how the matrix multiplication works, guys. And on the similar model, there is one passage question also. Okay, by the end of the class, I'll try to tell the year of the question. Yeah, there are good enough questions repeated in this model. What is that? I'll just tell you. Let's take two matrices and multiply. Okay, I know you hate this matrix multiplication because it is time taking, but I want to explain one important concept. Okay, so just 2 minutes. This and this, let's say. I'll take more zeros. 5 minus 1 0 0 0 3. Let's take like this. Okay. Now, when I'm multiplying these, what will I do? You know the multiplication. I'm not going to explain it again. I'll just write the result. You will get 10. Next, 1 minus 2 minus 1. Next, 3 plus 0 minus 3, 0. Next is 0, 15, 15. 0 minus 3. Next, this row and third column, 0, 0, 3. 5 minus 2 minus 1 minus 3 minus 6 0. Yeah. Okay. Now see what happens if you multiply the same matrix, okay, with the 0 5 0, which is first column of this matrix. What happens? Let's see. This row and this column, if you multiply 0 10 10, you will get. Next 0 15 15, you will get. Next 0 5 0 5. What are we getting? This it is the first column or not? Okay. So this column will give this column. Okay. And this column will give the second one. That means when you multiply the whole matrix with the second column, it will give you the second column on the right hand side. If you multiply the whole matrix with the third column, you will get the right hand side third column. Okay. That is the essence of this question. Now, here if you see matrix M into, every time it is matrix M multiplying with one of the columns. Correct? And each time you're getting different outputs. Yeah, it is expected now because second matrix is changed. Now, what if I multiply matrix M with 0, 1, 0, 1, minus 1, 0, and 1, 1, 1? Already they have given in the question. If matrix M is multiplied with 0, 1, 0, you're going to get minus 1, 2, 3. Isn't that what they have given? Okay. So the first column on the right hand side will be minus 1, 2, 3. Now what will be the second column? If you multiply matrix M with the second column, you are going to get 1, 1, 1, minus 1. Correct? If you multiply the matrix M with the third column, you are going to get 0, 0, 12. That's all. That is the basic funda which I want to. After this, you can do. Why I'll tell you? Because this is simply matrix M into A equals to some matrix B. So multiply with A inverse on both sides. A into A inverse is I only. M into I is equals to B into A inverse. What is M into I? M only. Any matrix into identity matrix is the same. No? That's it. To get the matrix M, you need to multiply the matrix B with A inverse. So basically, you need to find the inverse of this matrix. Okay. Everything is ones and zeros only. It will be easy to find. Okay. Not an issue. Okay, guys. So that is the concept in this question. Okay. Next. Yeah, this I think you can do easy question only. You can do it for homework. Let me just check any doubts or anything like that. Yeah, there are two n power minus 1. They cancelled with n square. Yeah, correct. Yeah, 23rd. Yeah. Next. Now, this is a very nice question, guys. Okay. Now, maybe this question looks tough, but I'll give a simpler question. Okay. To you first. Then I will get to this question. Okay. Let's say I have a determinant. Okay. 3 by 3. Now we are getting slowly into determinants. Okay. So 3 by 3 means, let me write it like this: A1, A2, A3. Same way. A4, A5, A6. Okay. Now what I am saying is, every number, that means A1 to A9, is an odd number. Okay. Positive odd number to be precise. Okay. Every digit, this is odd. Okay. It may be 11, 2173, anything. It is just given that it is odd. Every A1, A2, everything is odd. Then this determinant is always divisible by what number? Okay, so you can say that it is divisible by 1. Yeah, because no matter what is the answer, everything number is divisible by 1. Correct? But we are not expecting that kind of answer. The question is, yeah, I have written in the short form because I am lazy. Okay, that is, what is the, yeah, it is always divisible. What is the maximum number you can give? Okay. So that means if someone is saying it is always divisible by 4, and if other is saying 8, then if 8 is correct, then if some number is divisible by 8, it is obviously divisible by 4, correct? But which one is more appropriate answer? 8. Okay, that way. Fine. Now coming to the question, I hope you understood the point. The highest number, we have to say that the highest number which always divides this determinant value. Okay. Now you may say, sir, I will take 1, 3, 11, 25, 29, 381, 23, like that. Okay. But you can't keep checking, no? For every, you can make infinite number of this one. Okay. Now see, the trick is very simple. Okay. Now, if I do the row operation R1 as R1 minus R2, what will I get? Basically, I am doing A1 minus A4, A2 minus A5, A3 minus A6. And then I will also do R2 as R2 minus R3. Then this will become A4 minus A7. I will tell you there is a reason why I am doing this. A6 minus A9. Then it is A7, A8, A9. I can say for sure that all these will be even because odd minus odd, even only. Na? So this one will be even. So that means this is a multiple of 2, this is a multiple of 2, this is a multiple of 2. Like that, this is also multiple of 2, this one also is multiple of 2, this one is also a multiple of 2. You can't say that for third row because they are odd. Now, because since all are multiples of 2, you can take 2 common na, from first row. Because in determinants, what happens if you take a number common, you have to take common from every number in that row. So if you take 2 common, that's it, the 2 gone. You take another 2 common from the second row, then that 2 is also gone. So always, and then remaining whatever determinant is, it can be odd or even, we can't say anything on that. But finally, what is the conclusion? The final determinant value will be multiple of 4. 4 times some number, no? Because even after taking 2 common, all these entries will be integers. Since entries are integers, the determinant value will be integer at the end, positive or negative, whatever it may be. But it is going to be 4 times integer. So it will be multiple of 4, like that. Now this you try at home. Okay. Chalo, next. Yeah. Now I want to discuss something about adjoint. Okay. Rules of adjoint. Let me just check anything is there. Yeah. Acha, hint you want for this one. I'll tell you. Okay. First, let me complete the content. Then I'll come to whatever. Last 5 minutes I'll give for Aju. Okay, 5-10 minutes. Okay, coming to this, which of the following statement is always true? Okay, something they have given about adjoint and all these things. So I want to just revise that what is meant by adjoint of a matrix. Okay, adjoint of a matrix is nothing but, you know what? I like. You have to know about adjoint. Sorry, I can't explain because again time. Adjoint definition you see, you will understand it yourself. Okay, but what we do with adjoint is, if you want to find inverse of any matrix, just you find adjoint of that matrix. It is very easy to find adjoint of a matrix divided by determinant of that matrix. Okay. Now there are some important rules in adjoint. Okay, what are those? I'll just tell you. Adjoint of any matrix A is a delta into A inverse. That you understand, right? Okay. Because I'm just bringing that to the left side, delta. Okay. That is the first rule. Second, let's say, think about what is adjoint of A. Okay. So it will be adjoint of A is a matrix because delta is a scalar and A inverse is a matrix. Scalar into a matrix will be scalar. No? 2A is a matrix. Okay. 2 is a scalar, A is a matrix, but 2A will be a matrix again. Okay. So now adjoint of A is a matrix. Now adjoint of any matrix, you have to understand the first statement like this. Then only the next ones will be easy. Adjoint of any matrix is det of that matrix into its inverse. That's all. That is how you have to read. Okay. Now coming to the second point, adjoint of any, this is a matrix. No? What is adjoint of any matrix? Det of the matrix, because adjoint A is a matrix, into its inverse. What is the inverse? Adjoint of A is the matrix, its inverse. So we'll get det of adjoint of A. We'll talk about that. What is adjoint of A whole in? What is adjoint of A? Det A into A inverse. Its inverse. And we have seen already, data is a scalar. So K times a matrix inverse will be 1 by K, 1 by data. I'm writing it here, into data of adjoint of A into A inverse whole inverse, which will be A only. Okay. 1 by data into data of adjoint of A into A. Okay. Now we'll see what is data of adjoint of A. Data of K times any matrix will be nothing but K power n times data. Important rule. Okay. Where K is scalar and n is order of the matrix, order of square matrix. Okay. So det of adjoint of A will be det of, what is adjoint of A? Det A into A inverse, which will be, det A is a scalar, take it outside, det A power n into det of A inverse. Det A power n into det of A inverse will be 1 by det A. So we'll get det A power n minus 1. Okay. We'll talk about some questions on that also. Det of adjoint matrix is det A power n minus 1. Okay. Where n is order. So now, so that means if you have a 3 by 3 matrix, and if det of adjoint of the matrix A is 3 by 3, is 9, then what will be det A? Det of adjoint of A is det A power n minus 1, 3 minus 1, that is given as 9. Det A square is 9. So det A can be either plus or minus 3, any one of them. Okay, like that. So if det A is 5, then det of adjoint of A will be, for 3 by 3 matrices, 5 power 3 minus 1, 25, like that. Okay. Okay, fine. Now that we will use here. So second point, what we have written, final result, I will just write down. Adjoint of A will be simply det A power n minus 2 times matrix A. Now let me just give you a simple question. If I give you a matrix A, which is 1, minus 1, 3, 2, 1, 4, 5, 1, 0. Now at the beginning of adjoint, I told, na, finding adjoint is a process. Okay, that process involves finding cofactors and all these things. Okay, I hope that you already know it. Okay. Now adjoint of A itself is a lengthy task to find. Now the question is, what is adjoint of A? Or they may ask, find, like write the sum of diagonal elements in adjoint of A, like that. Okay. Now what is adjoint of A? It is simply det A power n minus 2 into matrix A itself. Now what is the order of the matrix here? 3 by 3. What is n here? 3. So det A into A. Now you just need to find determinant of the matrix, which is easy to find. Let's say, for example, in this case, I will take the third row, 5 into minus 4 minus 3 minus 7 minus 1 into 4 minus 6 minus 2 minus 35 plus 2, which is minus 33. So it is minus 33 times A. That's all. That is only adjoint of matrix A. Okay. Keep that in mind. Okay. This is one important rule. Fine. So if I just get into it, we have seen what is adjoint of A. Det of K is this. And det of adjoint of A is what here? Det A power n minus 1. Okay. Fine. Coming to this question. First question. First point. You see this sentence. Adjoint of a symmetric matrix is a symmetric matrix, they are saying. So that means, let's say A is a symmetric matrix. They are asking adjoint of A is symmetric or not. What we have learned before. If some information is given and you need to find whether other matrix is symmetric or not, what you do, you take it as X. Now let's see what is X transpose. Okay. It is adjoint of A whole transpose. Okay. What is adjoint of A? Data into A inverse. Correct? Transpose. Scalar is there means you can take outside. A inverse whole transpose. Data into. What is A inverse whole transpose? A transpose whole inverse. Already we have seen it. Okay. What is A transpose A? Because A is symmetric, na? What is data into A inverse? Adjoint of it. Right? So what is X transpose? Again, X only, na? So adjoint of a symmetric matrix is a symmetric matrix. Okay. That way you solve the other three. Okay. Other three are actually easy only compared to this one. See. Next. Any doubts are there? Let me just see. Yeah. This is fairly easy question because A into A inverse is I now. Multiply and equate it to I, you will get ABC, AC value. Okay. Yeah. Next important concept, guys. It is called characteristic equation. Okay. Now here you will see there is another concept which we have learned earlier. Na? That will also come here. Okay. It's a very nice question. Okay. You see guys. Now you come across these kind of questions. Now just you see the question, you will understand the difficulty of the question. But actually it is very easy to solve. Okay. You see this question. What is there? They have given a matrix A. Then they are asking A inverse. A inverse we can find. Because for any matrix, A inverse is adjoint of A by data. You can find A inverse. It is a time-taking process, but you can find. Okay. It is equals to, you have to verify with all four. Now imagine finding A square, that is multiplying A 2 times, A cube, multiplying A 3 times, A power. We don't know which one is answer. Okay. And you have to find A inverse. And all these nearly impossible to do within 3 minutes. Okay. So that's why we have something called as characteristic equation. Okay. Okay. Characteristic equation is something like this. Already, I hope you have an idea. Okay. So for a 2 by 2 matrix, characteristic equation is A square minus trace of A into A plus det of A into identity matrix equals to 0. Any matrix will satisfy this equation. Okay. That is the characteristic equation of any matrix. For a 3 by 3 matrix, it is A cube minus trace of A into A square plus trace of cofactor matrix. So I will explain what is trace of cofactor matrix plus det of A into I. You just need to know this. That means what is trace of any matrix? It is simply addition of diagonal elements. Like for example, here in this matrix A, trace of the matrix will be 3 minus 3 plus 1, which is 1. So A cube minus A square. Okay. Plus, what is trace of cofactor matrix? Simply nothing but, actually I can write it like this. Sum of cofactors of diagonal elements. Okay. So that means, what is the cofactor of 3? Minus 3 plus 4. It is 1. No? Cofactor of 3 is 1. Cofactor of minus 3, 3 minus 0. It is 3. Cofactor of this one, it is minus 9 plus 6. Minus 3, that is. Next, at last, Determinant. What is det? You can find using the last row. 0 is there now. So 0 into, so that is 0 only. Next, plus 1 into 12 minus 8, which is 4, minus 1 into minus 9 plus 6 again, which is minus 3. Yeah. Sorry, last one plus. No? Yeah. 4 minus 3, which is 1. So it is I. So basically, a cube minus a square plus a plus I. Wait. This is minus here. Okay. So in the next step, minus will come. It is alternate plus minus, guys. Okay. Like what I mean is, here minus is there, next plus, next minus, like that. Okay. We just substituted the values. Okay. Now, since a and I are commutative, na? If a and I are commutative, you can treat them like polynomials. Okay. So if I multiply with, you see, you need to have the polynomial idea also. What does that means? Identities. There are polynomial identities. No? At least that basic must be there. What is that? This is also important, guys. We use it in binomial theorem and all. What is x square minus 1? It is x minus 1 into x plus 1. What is x cube minus 1? It is x minus 1 into x square plus x plus 1. What is x power 4 minus 1? It is x minus 1 into x cube plus x square plus x plus 1. You are seeing some pattern, no? Everywhere x minus 1. And here the 1 plus x plus x square, 1 plus x square plus x cube. Like that, it will keep on increasing. Now, this one looks like this. Okay. What we do is, but minus is there. So what you do, replace x by minus x. What will you get? X power 4 minus 1 only. Here minus x minus 1. Here minus x cube plus x square minus x plus 1. Take that minus x plus 1 into x cube minus x square plus x minus 1. One way is doing like this. Okay. Or this is a GP. Okay, we'll forget all those things. Just simply we'll do this way. Okay, what you do now? You multiply with x plus 1. That means multiply with a plus I on both sides. One is like I. 0 into a plus I. 0 into any will be 0. So what is a plus I into? A inverse. No? Like, okay. I've taken a tougher example so that it will be, if easier question comes, it will be easy for you to solve. Okay. But these are the two important things which you should know. So this way. Okay. Next. We'll go to that one. And this we have already seen. Yeah. Next, coming to the very commonly, let me just see any doubts are there. Yeah, can you explain one more time? Okay. Yeah. See, just what I'm saying is, just remember this part. Okay. This is whatever box I have given. No? Any matrix will satisfy that equation. Okay. If it is a 2 by 2 matrix, the first one you have to do. If it is a 3 by 3, the second one. Okay. Once you do that, you get some equation. Okay. Now this is a tougher question. That's why we got a tough equation like this. Okay. So that's why we have to do a lot of manipulation here and then, okay. But actually the questions will be easy. Okay. It will not be so tough. The main gist of the concept is like this. If you can, it's not like this question will come in exam. No? So just the concept idea I'm giving. So this is called characteristic equation. for any matrix. Any matrix will satisfy it. Okay, like whatever I have written here. Now, when to use it? Whenever they give some questions which are based on something like this. A inverse in terms of A. They are not asking the matrix A inverse. What they are asking? They are asking to write A inverse in terms of A. Na? Okay. Yeah. Next. Yeah. I'll come to that question. But then this is a very common doubt which students have. And every year the question is coming. Okay. That is system of equations and the solutions. Now, simple guys, nothing. System of equations are divided into two parts, two kinds. One is homogeneous, other one is non-homogeneous. The terminology is very important here. Okay, homogeneous means the equations will be like a1x plus b1y plus c1z. Right side, all the constants will be 0. Okay, and same way a3x plus b3y plus c3z equals to 0. Non-homogeneous means simply on the right side, instead of zeros, you will be now having some d1, d2, d3. Okay, some constants will be there. Okay, next. You need to understand what is meant by trivial solution. First, what is meant by solution? It's the set xyz which satisfies all the given 3 equations. Okay. Okay. Now, what is meant by trivial solution? 0, 0, 0. Okay. Now, if you actually see in the homogeneous case, 0, 0, 0 will always satisfy these 3 equations. So what can I say? Trivial solution is always a solution. Always 0, 0, 0 will satisfy this homogeneous set of equations. So we can say that trivial solution is always a solution. Now here in non-homogeneous, 0, 0, 0 will not be a solution. Okay. Because the constants d1, d2, d3, they will not be 0. Na? So if you substitute 0, 0, 0, all 3 equations will not be satisfied. Okay, so where will you get the trivial solution? Only in the homogeneous case, not in the non-homogeneous case. Okay, next. Then we have 3 simple categorizations: no solution, unique solution, and infinite solutions. Okay, now this part is very easy. Unique solution. Simply det of a1, b1, c1, a2, b2, c2, a3, b3, c3. If this det is not 0, then the given system of equations will have unique solution. Okay. Now, in homogeneous case, how they will give this information is, they will not say unique solution. See, they will not be given these 3 equations and they will say this system of equations will have unique solution. They will not say like that. Okay. But let's say if the homogeneous equation has unique solution, that means unique means what? Only one solution. That one solution should be 0, 0, 0. So if I express it in language, it will be something like this. If trivial solution is the only solution, this is how the questions will start in homogeneous case. Okay, or they will say the system of equations doesn't have a non-trivial solution. Let me explain again. Okay. For example, let us take some. Okay, let me just take some example. Let's say these three equations are there, something like this. Now, don't bother about alpha, A, B, and all these things. Okay. Now, what do you mean by meaning of this question? It has a non-trivial solution. They are saying. Okay. What is meant by non-trivial solution? We know that trivial solution is 0, 0, 0. Then what is non-trivial solution? Something which is not 0, 0, 0. That is 1, 0, 0. Or you can have 7, 13, minus 8. All these are non-trivial solutions. Okay. Now, when I say a homogeneous equations have unique solution. Okay. Unique solution. Whether it is homogeneous or non-homogeneous. For unique solution, the condition is the det must be non-zero. That's all. Okay. For unique solution, the condition is det must not be. Okay. In homogeneous case, what is meant by unique solution? Trivial solution. Okay. In homogeneous case, trivial solution is the only solution. Okay. That is meant by unique solution. Or in other ways, it doesn't have a non-trivial solution. Like that also the question can be. Okay. So doesn't have a non-trivial solution means other than 0, 0, 0, there is no solution for the system of equations. That means unique solution only. Na? Okay. So that should be clear with homogeneous case. Next. Now, there is another word also. They will say infinite solutions. All these three means exactly same when it comes to homogeneous case. Whether they say, sorry. Yeah. Does not have infinite solutions. Not have infinite solutions, because if system of equations have infinite solutions, it means other than 0, 0, 0, there are solutions. That means it has non-trivial solutions. Okay, more than one. Okay, so simply in homogeneous case, all these three means the same. We'll solve the questions, the things will be more clear. Okay, now the doubt will come mainly no solution. Now this question will arise only in non-homogeneous case. Now this no solution situation will not arrive in homogeneous case. Why? In homogeneous, definitely 0, 0, 0 will be the solution. No? There is a solution. So no solution point will not come. Okay. Next, the only possibility will come, that possibility will come in non-homogeneous case. Okay. Infinite solutions, yes, it will come in both homogeneous case and it will come in non-homogeneous case. Now we have seen what is the terminology which will be used in the questions when it comes to unique solutions in homogeneous. So what they will say is, if trivial solution is the only solution, that means unique solution in homogeneous case. If they say the system of equations doesn't have a non-trivial solution, like that. Now here in homogeneous case, infinite solutions indirectly how they will be given is, system of equations has non-trivial solution. Understand the meaning, guys. When they say system of equation has a non-trivial solution, it means it has a solution which is looks something like this. Correct? It means it has more than one solution, that is infinite solutions. Here you have to observe that I have not written a column 5 solutions, because only these 3 cases are possible, guys. Okay. There is a AEEE question, that is JEE mains question, where they have asked, they have given some equations like this. Okay, some variables are there. They asked to find the value of lambda in these 3 equations. You can see there is lambda here. No? They asked to find the value of lambda for which the equation this system of equations has two solutions. That is the question which they have given. Now there is no such case. Okay, only three cases possible, guys. So no possible value of lambda is the answer. Only three possibilities: no solution, unique solution, infinite solutions. Okay. 0, 0, 0 means trivial solution. Okay. No solution case will only come for non-homogeneous case. It will not come for homogeneous case. And unique solution will be there for both. Infinite solutions will come for both. When it comes to homogeneous case, infinite solutions, in the question they will give like this: system of equations have a non-trivial solution, has a no. It means infinite. For non-homogeneous case, directly the language which will be used is this only. In non-homogeneous case, it is not a difficult task. They will say unique solution, no solution, like that one. Okay, let us come to the questions now. Okay. And what are the conditions also? We'll solve the questions, then you'll understand. Okay. Now they are saying the system of equations have no solution. Okay. Now I'll solve 4 questions, guys. Try to understand the model. Okay. Every year this question is coming, repeating. Okay. They've given 3 equations. And what they are saying, the system of equations has no solution. Okay. Write down first those equations. Plus y plus z equals to 1. X minus 2y plus z equals to minus 2. And last one is x plus y plus lambda z equals to 4. Now, they have given no solution. No solution means definitely it is not, it means it doesn't fall into unique solution category. Okay. If it is unique solution, that is not 0. If it is either no solution or if it is infinite solution, put det equal to 0. That's all. What is det? Minus 2, 1, 1, 1, minus 2, 1, 1, 1 lambda. Now what will I get if I solve for lambda? 1 into, I'm taking the third row. 1 plus 2, 3, minus 1 into minus 2 minus 1, minus 3, plus lambda into 4 minus 1, 3. So we are getting 3 lambda plus 6 equal to 0, which implies lambda equals to minus 2. Okay. So when lambda is minus 2, the system of equations will have no solution is what we are getting. Okay. Now here is the trick, guys. If det is 0, 2 possibilities are there. What are the 2 possibilities? Either it can be no solution or it can be infinite solutions. Correct? Now what you do is substitute lambda minus 2. What we are getting? Minus 2x plus y plus z equals to 1. This is the important step. Plus z equals to minus 2. Yeah, there is Cramer's rule to do, but always follow this. Why I will tell you. Okay, there is a reason. Minus 2z equals to 4. Now just do one simple step, because when you are using Cramer's rule, you have to solve for 4 different determinants, which is difficult. Okay. So why? Because there is, in Cramer's rule, what they say, if delta, delta 1, delta 2, delta 3, all are 0, then the system of equations will have infinite solutions. Correct? I will give you one example where this will fail. Okay. The example goes something like this. X plus y plus z equals to 1. X plus y plus z equals to 2. X plus y plus z equals to 3. Now you can say that just by looking, these 3 equations cannot be satisfied simultaneously. Why? If first equation is satisfied, what is x plus y plus z value? 1. Na? Then how can second equation be satisfied? And how can third equation will be satisfied simultaneously? But for this, if you find delta, delta 1, delta 2, delta 3, all will come 0. That doesn't mean infinite solution. Na? The actual answer is no solution. Okay. Okay, fine, guys. Now here is what, this is what I want you to do. Okay. So that's why don't just go with the equations. Just follow one simple step. See, till now what we have seen, there are only two cases broadly, either unique or it is no solution and infinite solution. I'm categorizing it like this. In unique, delta is not zero. In these two, delta will be zero. That's all. Now, delta zero I have done. I got lambda minus 2. Just write the three equations. Now, what you have to do is, now, automatically when you put delta zero, every time this happens, guys, using these two equations, you can get the third one, left-hand side. Only the left-hand side. In this case, it is very easy. Just add these two. What do we get? Minus x. I'm adding first equation and second equation. What will I get? Minus x minus y plus 2z. And what I'm getting right side? Minus 1. No? Multiply with minus sign. X plus y minus 2z equals to 1. Correct? That means use the first and second equation to match the left-hand side of third one. Okay? We have matched it. But did the right-hand side match? No. If they match, then it is infinite solutions. If they don't match, then it is no solution. That's all. Okay. Let me just repeat it for you. Now, for no solution and infinite solution, in both the cases, delta will be zero. So if they ask in the question, no solution, for example, like this, we will simply do delta zero. But delta zero may mean infinite solution or no, anything, na? But how you will be sure that it will be no solution? What you have to do is, after doing delta zero, you will get the value of lambda. Na? Here we got minus 2. Substitute in the question wherever lambda is there, you will get three equations, complete equations. Now using the first, second, or you can use second, third, whatever it may be. If you are using first and second, try to get the left-hand side of third equation. We are getting it. You will get it easily. Okay. The questions will be that way. Now then you see, using the first, second equation, are you getting the third equation completely or not? If you are getting the same equation, then it is infinite solutions. Same equation, then it is infinite solution. Using first and second. If you get the same equation as third, then infinite solutions. Otherwise, no solution. Okay. Let us take one more question like that. Now let us see here. Now this is very simple. They are saying unique solution. Unique solution means delta not equal to 0. No? Okay. Simple. Obviously, just by looking also, if you don't have time, you have to guess between these two. Okay. Let us take this one. Let me just check. Any doubts or anything? Yeah. Okay. Now this will be like one of the last questions, guys. Two more questions I will do. Then, okay. Remaining you can do it for homework. Okay. Let's come to this one. Okay. Because there are no variables involved. Now you have to find. Okay. Now, if it is a Cramer's rule, then you have to find 4 determinants. That much time will not be there in the exam. Okay. Simple. X plus y plus z equals to 8. First equation. Next is x minus y plus 2z equals to 6. Third equation is 3x plus 5y minus 7z equals to 14. Now they are asking unique solution or infinite solution or no solution. Okay. We know the answer will be either A, B, or C. There is no other case possible. Okay. Don't put none of this. Now delta you find 1. 1, 1, 1, 1 minus 1, 2, 3, 5 minus 7. Okay. Now it will be 1 into 7 minus 10 minus 3 minus 1 into minus 7 minus 6 minus 13 plus 1 into 5 plus 3, 8. So what are we getting? Minus 3 plus 13 plus 8. I think it is not 0, so unit solution directly you can do. Okay. Now, even if the dead becomes 0, okay, let us take this example. Okay, this one is easy only. This is also easy. Okay. Let us come to this one. Okay, this is a tough question. This J is subjective question actually, 10 marks question. Okay, so it will be lengthy. Actually, it is lengthy question, but we'll just x plus 2y. Last question for today, guys. But just concentrate. See the question. What they are saying that these three equations has infinite number of solutions. Definitely delta must be 0. So first you write delta 1, 2, 3, 1, lambda 2, 1, 4, mu. This must be 0, no? So what do we get? We get some big equation like 1 into lambda mu minus 8 minus 2 into mu minus 2 plus 3 into 4 minus lambda, which is equals to 0. So lambda mu minus 8 minus 2 mu plus 4 plus 12 minus 3 lambda equals to 0. So we're getting lambda mu minus 2 mu minus 3 lambda, 12 plus 4, 16 minus 8 plus 8 equal to 0. Something like this we are getting. Big complex thing. Okay. Now, oh yeah, one way is you can substitute them. Okay. Like lambda 2 mu 3. You substitute lambda 2 mu 3. What do we get? 2 into 3 minus 6 minus 6 plus 8. Let me just see the calculation. Minus 2 times mu minus 2 plus 3 times 4 minus lambda. Yeah. I hope I have written everywhere correct only. Yeah. Okay. So obviously it is not coming correct. Okay. 6 minus 6, but that is not. Lambda 2 mu 4. Put lambda 2. 2 into 4 minus 3 into 2 plus 8. I think this also is not getting cancelled. No? Okay. So mu 3 lambda 2 already we have substituted now. So this also is not getting satisfied. I think none of this should be the answer. Okay. Unless we have written something wrong in the question. Lambda 2, 1, 4. Yeah. That should be it. I'll just see for more appropriate question. Yeah. Let us see question number 52. Now what they have given? They have given 3 equations and they are saying no solution. If they give no solution or if they give infinite solution, only one thing you have to do. Det of the coefficients. Alpha 1, 1, 1 alpha 1 here. Next one is 1, 1 alpha. This must be 0. Na? Now, if you simplify alpha into alpha square minus 1 minus 1 into, what do we get? Alpha minus 1 plus 1 into 1 minus alpha. We'll get alpha cube minus 3 alpha plus 2 equal to 0. So alpha equals to 1 is satisfying. Okay. So let us put alpha equals to 1. What do we get? Because when alpha is 1, that will be 0. Now there will be other solutions also. Let us check for 1. 1 is very important. That's why. If you put 1, you will get x plus y plus z is equal to 0. Second one also x plus y plus z equal to 0. Third one x plus y plus z equals to 0. Just by writing the equations, you can see that it is infinite solutions because using 1 and 2, you can get the third because just first equation is third. Na? Multiply 1 into first equation plus 0 into second equation. That is third equation only. So infinite solutions. But they are saying no solution. Na? So keep it aside. So this case is infinite solutions. Okay. Next, -2 they are asking. Oh, let us see -2, is it satisfying? -8 plus 6 plus 2. Yeah, it is satisfying. So when lambda alpha is -2, this dead value is 0. Okay. Again, we get two possibilities, either no solution or infinite solutions. Let us see which one. Okay. They're asking no solution. No? Put alpha as -2. What do we get? -2x plus y plus z is equals to -3. Is equals to -3. Correct? Now, as we discussed, using the first and second, try to write the third equation. Okay. Now, how to write it? Combination. You see, something I have to multiply the first equation, and something I need to multiply the second equation to match the x and y coefficient. Okay, automatically z coefficient will be matched. Simply just add first and second. What do we get? If I add first and second, I will get -x minus y plus 2z is equals to -6. If I multiply by minus sign, I will get x plus y minus 2z equals to 6. Is it matching with the third equation? No. So if it matches, infinite solution. Otherwise, no solution. Okay. So now when alpha is 1, we got this infinite solutions. But when alpha is -2, we got no solution. Now what is the question they are asking? For which it has no solution. It is -2. Okay. That way. Fine. Yeah. Okay, guys. So I'll stop the session here today. Okay. Yeah, this is a big topic, matrices and determinants. So that's why, like, whatever possible I've done. Okay. Yeah. So just for the next class, no, just revise the concepts beforehand and come. Let me just tell you what will be the next topic. Okay. Just a moment. I'll just tell you now. Your next mathematics class will be on straight lines and pair of straight lines. Thank you. Thank you very much, guys. Yeah. Next class will be, yeah, let me just tell you, it may be tomorrow only. Next class will be on 19th, 19. Okay. Straight lines and pair of, yeah, I will ask for recording. Yeah, I will send PDF. Okay. Straight lines and pair of straight lines. Okay. Okay, guys. See you on 19. Straight lines and pair of straight lines. Okay. Tomorrow will be chemistry. Yeah. Okay, guys. All the best. See you again on 19th. Okay. Bye.